This is Algebra 2 with Trig. This is a Unit 1 review. So the first thing we're looking at here is we're going to find the center and the radius of a circle. We need to list our variables like so. We need to get the x's together, we need to get the y's together. Then we take the b value, divide it by 2, and square it. That's -6 squared, which is 36. So we're going to write our x squared minus 12x and add that 36 to this side. Plus, we'll take our b term, divide it by 2, and square it, which is 1 squared, which is 1. Y squared plus 2y, add the 1. We added the 36, we added the 1 onto the left side of the equal sign. We also need to add it onto the right side of the equal sign. Since there's no leading coefficient, we have to worry about multiplying through. So the whole point of this guy is that it is -6 squared. -6 being squared gives you 36, and added together gives you -12. This is going to be y plus 1 quantity squared. And here we have -14, positive 22. Find the center. Looks like that's going to be 6, -1. And our radius is going to be the square root of 22. Which is a little bit more than 4, but less than 5. On this side, now this is funny, this has a -x squared. Well, I don't want to have my negative signs, so I'm going to throw it over to the other side. So I'm going to leave 129, add my x across, add my 4x across, that's my x squared and my 4x, leave some room, add my y squared across, subtract my 12y across. That's going to take my b term, divide it by 2 and square it. That gives me 2. 2 squared is 4. So we have x squared plus 4x plus 4. That's one trinomial, perfect square trinomial. And on this side we take our -12 divided by 2 and square it. That's -6. That's 36. We add that to the right side. Well, if we added those to the right side, we also need to add those to the left side. So we're going to add 40 onto this side. That's 169. So we have x plus 2 quantity squared and y minus 6 quantity squared. There's my circle. My center is at -2, 6, and my radius is the square root of 169, which is exactly 13. Here we're going to take the square root. We're going to break this guy down. This breaks down into 2 times 121. Well, the square root of 121 is 11, so we have 11 root 2. So this is supposed to be multiplication. You have the square root of 10 and the square root of 14. You could think about that as the square root of 2 times 5 times the square root of 2 times 7. There's a pair of numbers. You could call that 4, and the square root of 4 is 2, or a pair of numbers comes out as a single value. These two go inside as 35. This guy we need to multiply by the conjugate. You multiply the bottom and the top so we can get rid of the square root. 12 minus 3 root 5. This gives us 16 minus 4 root 5 plus 4 root 5 and a -5. So the top is still 12 minus 3 root 5. And the bottom, the 4 root 5s cross out because one's negative and one's positive. We get 11. We can write it as a single fraction because they're real numbers. This isn't imaginary. So we can write it as a single fraction. Our conjugate, we get negative 30 minus 6 square root of 11, 25, plus 5 square root of 11 minus 5 square root of 11, minus 11. That gives us negative 30 minus 6 root 11. 10 less would be 15. 11 less is 14. And we notice that there's a 2 in all of these. So our final answer is going to be negative 15 minus 3 over 7. So here, for a period of 48 months, the average monthly operating cost for a small business can be approximated by this equation, where T is the number of months. During which month was the average operating cost $1,430? Well, what we're trying to figure out is, when do we get that value? So I'm going to subtract 550. So give me 0. We get 8, and that's a 13. So we get 9, 8, 7, 8. Same thing. Silly me. So there's that. Equals 0.55 square root. So next we divide by our 0.55. And with a calculator, we see that we get 1,600. We can take the square root of both sides, and your time's going to be plus or minus 400. But we're talking about time, which in this case, it's not seconds, it's the number of months. So I'm under the impression that that's 400 months. Let's see if that makes sense. If we're trying to get up to here, so we're going to take 0.55 and times it by 400 months squared, and then we'll add 5,500 to that. Oh, it's 40. Ugh. Of course, square root of 1,600 is 40. Not, see, test your work and you find out that you're way off. Bad approximation skills. So, there it is. That makes more sense. 400 seemed huge, so I checked my work to see that I was a 0 off. Okay, the height of a triangle in inches is 4 inches less than the length of the base. So the height of the triangle is x minus 4 if x is the whole thing. And we know the area is 30. So the area equals half of base times height. 30 equals half the base times the height. So we multiply by 2 to get 60, and we distribute to get x squared minus 4x. Let's see. If we minus 60 here, let's see if this is factorable. X squared minus 4x minus 60. So to multiply to be 60 and add to be negative 4, I know the two signs have to be opposites and the larger number is negative. So 1 and negative 60, 2 and negative 30, 3 and negative 20, 4 and negative 15, 5 and negative 12, that's 7, 6 and negative 10, there it is, there's the negative 4. So x plus 6, x minus 10, that multiplies to be negative 60, that adds to be negative 4. So now you do the zero product property to figure out that x is going to be negative 6 or x is going to be positive 10, and of course x cannot be a negative number because it's a length of geometry, so 10 is our only. Find the height and the base. The height is 6 and the base is 10. Those are inches. The dimensions of a rectangular garden are 10 by 25. You want to quadruple its area, multiply it by 4, by adding the same distance of x onto both. So down here, let's get at least a little visual of what's going on. So we have 10 by 25. That would give me an area of 250. If we take our 250 and quadruple that, we want an area of 1,000. We're going to have an area of 1,000 by adding the same distance to the length and the width. So find the area of the current. The current is 10 times 25, which is 250 feet squared. Write an equation to find the value of x. Well, we're going to have the length of x plus the 10, and we're going to have x plus the 25, and that is supposed to be 4 times 250. So x plus 10, x plus 25 equals 1,000. That would be my equation. Find the value of x that helps reach the desired area. So here we're going to have x plus 10, x plus 25 equals 1,000. We get x squared plus 35x plus 250 equals 1,000. So we'll subtract 1,000. X squared plus 35x minus 750. So now we're trying to figure out what multiplies to be this and adds to be that. I don't know. So we're going to do, we know that the larger number's got to be positive. I always suggest to start with 1. So 325. 3 goes into there way too many times, but 3 goes into there 2 times with 1 left over. 4 doesn't go in there evenly. 5 goes into there 1 time with 2 left over. 6 goes into there 1 time with 1 left over. That's 15, so that's 2 times with 3. Seven's not going to go in there evenly. So 7 doesn't go into there. 10 goes into there. 75 times. And 15 goes into there 35 times. No, 15 goes in there 50 times. And that's our answer of 35. That adds to be 35. So we got our dimensions of negative 15 and x plus 50. And then we can do the zero product property. So we got x equals 15, or we got x equals negative 50, and of course it's got to be a positive value. So let's see if this is going to work. We're going to take our 10 and add, let's see, 10 and add 15 to it. We'll take our 25 and add 15 to it, and we get our 1,000. So that was what we were trying to get. Find the length and the width of the new garden. So x equals 15. So we're going to say 15 plus 10 and 15 plus 25. So that's going to be feet and feet. These we should not be using our calculator for. We're looking for two numbers to multiply to be 8 and add to be 6. Kind of a guess and check format there. Here's the difference of two squares. We can take the square root. I like to call it x squared minus 10 squared, so we have x minus 10 and x plus 10. Difference of two squares again. We have a 3x that's being squared to make 9x squared. We have a 4 that's being squared, so 3x minus 4, 3x plus 4. We have a common factor we can pull out of this one. So, using a little bit of guess and check format here, we know the beginning has to be a 2x, and we know the back end has to be 3 times 1. So this has to be 3 and 1 to get 6 and 1, so a positive 6, negative 1. That's the guess and check format. Here, difference of two squares again. We have 5x being squared, and we have 10 being squared. So we're going to have a 5x minus 10 and a 5x plus 10. But notice that they both have a 5 in them. So we got to bring a 5 out and another 5 out. So that's 25, which would leave us x minus 2, x plus 2. When you factor the 5 out, that would be 5 times x and 5 times 2. So that's why it's x minus 2 and x plus 2. You could have factored out the 25 first. And then that you can take the difference of two squares. Here this has a GCF, so we pull the GCF out. And as a leading coefficient, that's 1, so it's a little bit easier to do. So we got 5 and 1, multiplies to be 5, adds to be 6. Here I can pull a 3 out. It looks like a 3p would be the only thing that could come out. And that would leave me with 6p minus 1. And that's the only way to get to factored. Here we could talk about a times c, which is 30. That adds to be 31. Well, that's 1 and 30. Multiplies to be 30 and adds to be 31. So that's 5x squared plus x plus 30 plus 6. Circle my two groups. That would be 30x. Circle my two groups. I can factor out an x here. Factor out a 6 here. Leaves me with 5x and a positive 1. Notice that what's inside my parentheses is exactly the same. The x and the 6 are both multiplying the 5x plus 1. The x distributes just like FOIL would, and then the 6 distributes just like the rest of FOIL would. Difference of two squares. I notice that 2y being squared and 5 being squared. The middle term is 2 times those two multiplied together. So I get my A term, which is 2y, and I get my B term, which is 5, and that's the quantity squared. This is a perfect square trinomial. I tested it. I looked for what was the square root of 4y squared, what was the square root of 25, and was the middle 2 times those two multiplied together. The answer was yes, so I could write it as 2y minus, because it's a minus 20. That sign comes all the way down, definitely comes all the way down. So we're supposed to solve. So it looks like we're going to be solving using square roots. And divide by 2. Oh, not 42. We're adding. That gives us 81. That works a lot better. So I take the square root of both sides, and I get w minus 2 equals plus or minus 9. So w minus 2 equals 9. W minus 2 equals negative 9. Add it. Add it. Here I got to solve. And I look for what multiplies to be 10. So if you look at what multiplies to be 10 and adds to be 6, you get 1 and 10, you get 2 and 5. Those are the only ways. Neither of them is 6. Okay, so it's not factorable. So let's see if we can figure out the x values, if there are any, by subtracting the 5 to the other side, factoring out to 2, and trying to complete the square. Oh, the square got a little ugly here. 3 divided by 2 squared equals 9/4. So we're going to add 9/4 here, and we'll get 18/4 when we multiply it on the other side, because you got to do twice as much with your leading coefficient. That's what you got to add to the other side. So this is going to give us 2 up, and this is going to be a negative number. So what's going to happen here? Let me show you. This value here is 4 and 2/4, so 4.5. So this is a negative number. So negative 5 plus 4.5 is negative 1/2. So we get a negative value. Another way to test this out is to do the b squared minus 4ac. 36 minus 4 times a times 5 is 36 minus 80. That's a negative number. So this is not factorable. That determined if it was factorable. Because it was negative, that determined if it had real solutions at all. So it did not have real solutions because your discriminant was negative. I checked my work here to see if I could factor, and I couldn't come up with anything. I tried completing the square, and it gave me a negative that I'd have to take the square root of eventually. I checked it with the discriminant to verify that I had no real solutions, and they all came up to the same thing. There is no way that x could make that occur. x squared minus 22. I don't need to rewrite it, I guess. I'm going to take my b term, divide it by 2 and square it. And we'll add that to both sides. And that's going to give me x squared minus 11, quantity squared. 121 minus that, minus 21 would give me 100. Minus 31 is going to give me 90. No longer have a square there. Take the square root of both sides. That's x minus 11 equals plus or minus 90. So add the 11 to both sides. And we get plus or minus the square root of 9 times 10, so 3 root 10. You can't collect like terms, so you can leave it in that format. So here we multiply to get 6x squared. Oh, wait, don't need to do that. That would be crazy work. These two binomials equal 0, so I can do what's called the zero product property. And add the 7 and divide by the 2. Subtract the 2 and divide by the 3. You could put that in standard form and then work it all out again. You'd get the same answers. Here we only have one type of x. It's x squared. So we can collect our like terms together. And when we divide by 7, and we take the square root, maybe I should have done this with that other one we called prime, huh? Negative 2/7. So we would root 7 and root 7, which would give us an I number because it's negative, a square root of 14 on top, and 7 on the bottom. So you could write the I here, and you could actually write it in the back, but I like there in front. So let me slide back up here. Let's think this one out. If we're supposed to solve it and we're dealing with negatives, we could actually solve that one and get an imaginary answer. So be it. Imaginary it is. So we're going to divide by the 2. X plus 3/2 squared equals, when you divide it, you get 1/4, still negative. Take the square root of both sides. X plus 3/2 equals the square root of negative 1/4. Well, that's going to be x equals negative 3/2 plus 1/2 I, plus or minus 1/2 I. We could leave it like that. When you take the square root of 1/4, you take the square root of 1, which is 1. Take the square root of 4, which is 2. So you take the square root of both of them, so no more radical. You have the negative, so that's the I. You have the negative 1/2. So that's our best answer for number 11 also. Imaginary numbers. Whenever you have two different types of x's, you want to bring everything over to the same side. And if we're solving, we don't need to have a greatest common factor. So I'll take a multiple of 2 out of this. You could think about it as dividing it to the other side. What multiplies to be 12, negative 12, and adds to be negative 4. That would be 6 and 2. Negative 6 and a positive 2 would get us what we need. So 4x squared minus 6x plus 2x minus 3. Factor out what we can. Bring down my sign. Oh, I can only factor out a 1, so I have to put the place value in there. 2x minus 3. That gives us 2x plus 1 times 2x minus 3. That still equals 0. So when I do the zero product property to this, I get two answers. I get an x to be negative 1/2, and I get an x to be positive 3/2. I'll stop this video here, and you can pick up the rest of it on the next one.